Welcome back to the third tutorial in this series. Today I'm going to demonstrate the mesh current method. I'm going to use the same problem we used for nodal analysis. Here it is. Use mesh current technique to find the value of the current I0. The first step in the mesh current method is to identify the meshes and to label them with circulating currents. In this circuit we have three meshes. Here's 1, 2, and 3. So let's add the three currents. Here are the mesh currents labeled. Notice, however, that there is a current source between meshes 1 and 3, and therefore we cannot write a KVL equation through the current source. So here's where we need to use a super mesh. So let's join mesh 1 and 3 and create a big mesh, and here it is. Here's our super mesh. The next step is to write KVL equations for mesh 2 and the super mesh. Notice that mesh 2 has 3 branches. Therefore, the mesh current equation must have 3 terms. Let's look at the equation for mesh 2. First, we multiply 4 by the current I2, and then plus 2 times the difference between I2 and I3, because for the 2 ohm resistor there are 2 mesh currents that pass through this resistor. So we have 2 I2 minus I3, and then we have this 10 ohm resistor. Again, we take the difference between I2 and I1, and this equals to 0. So here's our mesh 2 equation. Now for the super mesh equation, let's start at the voltage source. So we have minus 60 plus, again, 10 I1 minus I2, and then we go up here 2, and then we take a difference between I3 and I2, and finally plus 8 times I3, and this equals to 0. So far we have 2 equations but 3 unknowns, I1, I2, and I3. We therefore need a third equation. This extra equation comes from the current source, ignored when creating the super mesh. From the figure, the relationship between the dependent source and the 2 mesh currents, I1 and I3, is given by this equation. I3 minus I1 is equal to 3 I0. And the reason it is I3 minus I1, not I1 minus I3, is that I3 is in the direction of the current source, while I1 is in the opposite direction. Okay, so although we've added a third equation, a fourth unknown has come up. Now we have I0. So we need one more equation, and luckily we can express I0 in terms of the mesh currents. From the figure, it's clear that I0 is equal to mesh current 2, I2. So let's add this extra equation. And now we can substitute equation 4 into 3 and rearrange the 3 equations to get the following. This is mesh number 2 after simplification, and this is the super mesh equation, and finally here's the extra equation. Now solving these linear equations for the mesh currents give I2 equals 1.73, and because I0 is equal to I2, then I0 is equal to 1.73 amps. Notice that this is the same answer we got when using the nodal method. And this is the end of this example. Wonderful. I'll see you in the next tutorial.